Hello, everyone. Good afternoon, and welcome back. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, broadcasting live out of Valley, California.
Yep, and we are talking science today. Definitely.
Yeah,
This
it's
is
pretty
cool.
cool. What you see on your screen is the formation of a gas giant like Jupiter, a giant planet that it's still forming. There's swirls of stuff around it that's going to collide and make it bigger. It's an artist rendition, but the next one we show you a little bit in, you'll see what the astronomers are seeing. A seemingly quiet star just gave up one of the universe's best kept secrets, a massive gas giant forming in its dusty disk. For years, MUS appeared featureless, no planets, no gaps, no drama. But when scientists used deeper ALMA imaging and paired it with stellar wobble data from Gaia, a dramatic picture emerged. A planet up to 10 times the size of Jupiter.
That's big.
That's Super Jupiter,
Yeah.
right? Hiding in plain sight. This marks the first time such a hidden world was detected using this method, suggesting many more young, camouflaged planets could be waiting in the fog around other stars. This is just if you when you're looking at this slide, some of you may find this very familiar
We don't even know if this
from a
has ever
certain
happened
place.
in recent time, right? That a planet is formed like this and we get to watch it being formed.
Well, like if light travels, then maybe that was formed a million years ago. What we're seeing. But
Pretty cool.
this is how the saviors created, the universe just like this.
Yeah.
The findings were published on July 14th, 2025 in Nature Astronomy. Would you like to know more?
Astronomers have discovered a massive planet estimated to be between 3 and 10 times the size of Jupiter, hidden within the thick disk of gas and dust surrounding a young star. The star, known as MP-MUS, was previously believed to be alone with no signs of orbiting planets.
Oh,
Earlier observations showed nothing more than a smooth, featureless cloud encircling it, and that we can see that on the slide, right?
yeah.
But sorry, new data paints a very different picture using detailed observations from the Atacama Large Millimeter Submillimeter Array, ALMA, like you called it earlier,
Mhm.
along with measurements from the European Space Agency's Gaia mission. Scientists have found evidence of a giant planet orbiting the star.
Yeah. So do we advance the? Nope. We still got to keep going. Okay. Led by researchers at the University of Cambridge, the international team detected a gas giant embedded in what's called a protoplanetary disk. Now we've talked about that with proto Earth, right? And Theia slammed into it, created our moon, right? A flat, rotating band of gas, ice, and dust where new planets begin to form. This is the first time that data from Gaia has been used, and it's spelled GAIA. If I'm butchering it, I'm sorry. Has been used to identify a planet inside such a disk. The findings point to a promising new method for finding young planets still in the process of forming. Okay, we're going to advance the slide here. If I can get to it. There we go. So this is what the astronomers see right here.
It's like a couple of headlights, right?
Mm-hmm.
When
Well, it's one picture next to each other. One
oh,
previous and one with the ALMA.
okay, gotcha. When astronomers first observed it with Atacama Large Millimeter Submillimeter Array, ALMA, they saw a smooth, planet-free disk shown here in the right image. The team, led by Alvaro Ribas, an astronomer at the University of Cambridge in UK, gave this star another chance and re-observed it with ALMA at longer wavelengths that probe even deeper into the protoplanetary disk than before. These new observations, shown in the left image, revealed a gap and a ring that had been obscured in previous observations, suggesting that MP-MUS might have company after all.
Okay. Studying the formation of planets inside protoplanetary disks helps scientists better understand how our own solar system came to be in a process called core accretion, carving out noticeable gaps similar to grooves on a vinyl record. That's what, like, Saturn's got those.
Yeah,
Yeah.
rings. Right.
Yeah.
However, observing these young planets is extremely challenging due to the interference from the gas and the dust in the disk. To date, only three robust detections of young planets in a protoplanetary disk have been made. Dr. Alvaro Ribas from Cambridge's Institute of Astronomy, who led the research, specializes in studying protoplanetary disks. Quote, "We first observed this star at the time when we learned that most disks have rings and gaps, and I was hoping to find features around MP musts, the planets."
In 2023, the results showed a young star seemingly all alone in the universe. Oh, that's so sad, isn't it? It's sad.
I'm not worried about it.
Its surrounding disk showed none of the gaps where planets might be forming and was completely flat and featureless. Quote, "Our earlier observations showed a boring, flat disk," said Rebus.
So not only was it alone, it was ugly.
And boring, yeah. It was ugly. Yeah.
Yeah.
Like the duckling. Aw. Aw. Quote, "But this seemed odd to us since the disk is between 7 and 10 million years old. In a disk, how do they know that? By looking at a picture.
I don't know.
In
These
a
guys
disk,
are like weathermen. You know, they get to just take a shot. Today it might rain.
50-50,
It's going to
man.
rain today, maybe. But anyway,
In a disk of that age, we would expect to see some evidence of planet formation.
now Rebus and his colleagues from Germany, Chile, and France have given MP Mus another chance. Once again, using ALMA, they observed the star at the 3 millimeter range, a longer wavelength than the earlier observations, allowing them to probe deeper into the disk. The new observations turned up a cavity close to the star and two gaps further out, which were obscured in the earlier observations, suggesting that MP Mus may not be alone after all.
Hmm.
Well, there you go.
At the same time, Miguel Vioque, a researcher at the European Southern Observatory, ESO, was uncovering another piece of the puzzle. Using data from Gaia, he found MP Mus was wobbling.
Huh.
So he says, "My first reaction was that I must have made a mistake in my calculations." That's what I would think that. Because because MP Mus was known to have a featureless disk, said Vioque. He continues to quote, "I was revising my calculations when I saw Alvaro give a talk presenting preliminary results of a newly discovered inner cavity in the disk, which meant the wobbling I was detecting was real and had a good chance of being caused by a forming planet."
Using a combination of Gaia and ALMA observations along with computer modeling, the researchers say that the wobbling is likely caused by a gas giant less than 10 times the mass of Jupiter, orbiting the star at a distance between 1 and 3 times the distance of Earth from the Sun.
That's habitable.
Yeah.
It's an habitable zone.
Okay. Quote, "Our modeling work showed that if you put a giant planet inside the new found cavity, you can also explain the Gaia signal," said Rebus. "And also using the longer ALMA wavelengths allowed us to see structures we couldn't see before."
Like buildings?
I don't know. I mean, that's crazy.
This is the first time an exoplanet embedded in a protoplanetary disk has been indirectly discovered in this. The first time in this way. By combining precise star movement data from Gaia with deep observations of the disk.
Huh.
It also means that many more hidden planets might exist in other disks, just waiting to be found.
Okay. Quote again, "We think this might be one of the reasons why it's hard to detect young planets in protoplanetary disks, because in this case we needed the ALMA and Gaia data together," said Rebus. Quote again, "The longer ALMA wavelength is incredibly useful, but to observe at this wavelength requires more time on the telescope."
Yeah, so people are clamoring to get time on the telescope.
I guess so. Build another telescope.
There you go. Rebus says that upcoming upgrades to ALMA, as well as future telescopes such as the next gen Very Large Array, may be used to look deeper into more disks. So it's the mother of all arrays, right?
Okay.
Right? Moab, mother of all
Very, very
arrays.
large.
Yeah.
Okay.
May be used to look deeper into more disks and better understand the hidden population of young planets, which could, in turn, help us learn, ergo, how our own planet may have formed. Elementary, my dear
And then
Watson.
and then we're going to take AI and we're going to start forming our own planets.
Let's do it, man. Let's
And
do
that'll
it.
be the stepping
Send
stone to Mars.
send robots there to start mining,
Yeah, and beyond. Right.
right? And
Yeah.
to infinity and beyond.
To infinity, right. Yeah.
All right, folks. We're kind of lighthearted, but it is pretty cool stuff that they're
Yeah, very
discovering
cool.
here.
Very cool. So thanks
All
for
right.
listening and watching. Take care.
Okay, we'll talk to you later. All right, where's that button here? We're still on. Here we
We are.
go. Here we go. There we go.